To manage data at scale, developers use object-oriented programming. It is the system we use to organize code into reusable structures. But when you first write a Python class, it can feel like nothing is happening. You can define a class and run your script, but the computer won't actually create any data or allocate memory for it yet. This diagram illustrates why. A class is a conceptual template, much like an architect's blueprint for a vehicle. The blueprint details exactly what the car should look like, but the blueprint itself isn't a car you can drive. When you write properties inside this template, like setting a color to red, you aren't painting an actual vehicle. You are simply establishing a default rule for any objects you build later using this design. At this stage, the class is just a set of instructions. It remains inert until you tell Python to use those instructions to build something real. To turn those instructions into data, you have to instantiate the class. This is the process of spawning an actual object from your template. This graphic shows the syntax required to create that instance. By typing car1 equals car, you execute the blueprint. This generates a concrete data block in the computer's memory, linked to the variable car1. If we look at the internal details of this specific object, we can see it now carries that red property. It's no longer just a plan, it's a piece of data we can use. Seeing them side by side, we can see they are separate. The original blueprint remains unchanged on the left, while our active car1 object exists as its own entity on the right. Without this step of instantiation, the blueprint is just text on a screen. You need the object to actually hold and manipulate information. Now that we have an object, we need a way to reach inside it and see its details. We do this using dot notation. This diagram shows the retrieval syntax. In the command print car1.color, the dot itself acts as the bridge. It tells Python to look inside the car1 object and find the value assigned to color. We use that same bridge to change data. By typing car1.color equals blue, we assign a new value to that specific object, changing its state without affecting anything else in the program. Apply this logic to a different example. Imagine building a system to track students, where each student object needs a name. This code block shows the steps. Define the template with class student, create the individual profile with student1 equals student, and then access the name property with student1.name. This comparison highlights a common mistake. If you try to print car.color using the class name, the program will crash or fail to find the data. You must use the object name, car1, because the class name is just the name of the blueprint, not the data itself. Every interaction, reading, writing, or changing information, happens at the object level. The template simply sets the stage. Then there is a clear distinction between the conceptual class and the tangible object. One defines the rules, and the other holds the actual data. This flowchart shows the three-step process for every object. First, define the class. Second, instantiate the object. Third, interact using dot notation. This strict order is mandatory. You cannot interact with an uncreated object, nor create an object without a definition. Mastering the separation between the blueprint and the data is the first step toward writing programs that are organized